Hello everyone. In this session, we will learn about masonry mortar together. Through several images, we can see that the Great Wall, Chow's Courtyard, castles, and residential dormitory walls are all constructed using building mortar. Before learning about masonry mortar, let's first understand the concept of mortar. Mortar is a building material composed of binding materials, fine aggregates, and water, prepared in appropriate proportions. To improve the workability of mortar, appropriate additives and admixtures can be added. Mortar can be considered as concrete without coarse aggregates, or concrete with a sand content of 100%. Therefore, many principles of concrete also apply to mortar, but due to the thin layer application and often being spread on porous, absorbent, and uneven substrates, there are specific requirements for mortar. This session introduces students to masonry mortar and its technical properties. The content of this session includes three aspects: the concept of masonry mortar, material composition, and technical properties. First, let's learn about the concept and material composition of masonry mortar. Masonry mortar refers to the mortar that binds bricks, stones, blocks, etc. to form masonry structures. It serves to bond bricks and blocks, transmit loads, ensure relatively uniform stress distribution, coordinate deformation, etc., making masonry mortar an essential component of masonry structures. The composition of masonry mortar is similar to that of general mortar, consisting of binding materials, fine aggregates, water, admixtures, and additives. Main types include cement mortar and cement lime mortar. Next, let's focus on the technical properties of masonry mortar. The properties of masonry mortar include those of freshly mixed mortar and hardened mortar. A freshly mixed mortar requires good workability, while hardened mortar needs to possess the required strength, bond strength, and minimal deformation. One aspect is the workability of freshly mixed mortar. The workability of mortar includes two aspects: flowability and water retention. Flowability. It refers to the ability of mortar to flow under its own weight or external force, also known as consistency. Flowability is measured using a mortar consistency meter and expressed as penetration depth in millimeters, mm. When measuring the flowability of mortar, the mortar to be tested is first uniformly placed in the mortar cylinder of a mortar consistency meter. Placed under the cone of the meter, the cone tip with a mass of 300 grams, and a sliding rod is brought into contact with the mortar surface. Then the sliding rod is suddenly released, and within 10 seconds, the depth to which the cone penetrates into the mortar is measured as the penetration depth. Therefore, the greater the penetration depth, the better the flowability of the mortar. When selecting the consistency of mortar, it should be determined based on factors such as the type of masonry material, construction conditions, and climate. Refer to Table 5.1 for selection. 2. Water retention. The ability of freshly mixed mortar to retain moisture during transportation, storage, and use is called water retention. Maintaining a certain amount of moisture in the mortar not only facilitates handling, but also ensures proper hydration of cement, guaranteeing the strength of the masonry. Adding an appropriate amount of plasticizer can significantly improve the water retention and flowability of mortar. The water retention of mortar is represented by the water retention rate, which is determined by the water retention test. The instruments and materials used in the test include a ring mold with an inner diameter of 100 millimeters and a height of 25 millimeters, a 0.045 millimeter mesh sieve, 15 pieces of filter paper, a 2 kilogram weight, a non-permeable bottom plate, an oven, etc. From the test, we could know the water retention rate equals water content of mortar minus water bleeding amount, then divided by water content of mortar and times 100%. The water bleeding amount here refers to the amount of water absorbed by the filter paper. And typically, the water retention rate of cement mortar should be greater than or equal to 80%. Cement mixed mortar should be greater than or equal to 84%, and premixed mortar should be greater than or equal to 88%. The second aspect is mortar strength and strength grade. Hardened mortar should have a certain compressive strength. Compressive strength is the primary basis for classifying mortar grades. The standard test specimen for measuring mortar compressive strength is a cube with a side length of 70.7 millimeters, tested in a group of 6, and cured for 28 days to determine the average compressive strength. Masonry mortar is classified into 7 strength grades based on compressive strength, including M30, M25, M20, M15, M10, M7.5, and M5.0. In addition to being influenced by the materials and proportions of the mortar itself, mortar strength is also related to the water absorption performance of the substrate. When the substrate does not absorb water, the strength of the mortar depends on the cement strength and the water-cement ratio according to the formula. In the formula Fm, 0 refers to the compressive strength of mortar at 28 days, and A and B are characteristic coefficients that can be determined experimentally or obtained from tables. Therefore, mortar strength depends on FCE and C divided by W. FCE is the actual strength of cement at 28 days, and C divided by W is the cement-water ratio, the reciprocal of the water-cement ratio. When the substrate absorbs water, the strength of the mortar mainly depends on the cement strength, FCE, and the cement quantity, QC, regardless of the water-cement ratio. Because the substrate absorbs water, it changes the water-cement ratio of the mortar, thereby affecting the strength of the mortar. The third aspect is the adhesive force of mortar. Masonry mortar must have sufficient adhesive force to bond bricks and stones into a solid whole. The magnitude of mortar adhesive force will affect the shear strength, durability, stability, and vibration resistance of masonry. From the perspective of masonry integrity, the bond strength of mortar is more important than compressive strength. There are 4 factors that affect bond strength. 1. Mortar with excellent water retention typically exhibits good bond strength. 2. Higher mortar strength grades generally result in greater bond strength. 3. It is related to the cleanliness and wetting condition of the masonry material's surfaces. Therefore, pre-wetting of masonry units before construction is done to enhance the bond strength between mortar and units. 4. It is related to construction and curing conditions. Through the study of masonry mortar and its technical properties in this section, we should also be aware that consistency, segregation, and compressive strength are the 3 essential inspection items for masonry mortar. If all 3 meet the specifications, the mortar is considered qualified. That's all for this lesson. Thank you.